Hi, Math 2. This is notes for Unit 6, Lesson 12, and we're on page 90 of your workbook. So, Lesson 12 brings together both lessons 10 and 11. It's about parallel lines and perpendicular lines on the same graphs. So in this problem, the image shows line N. You can see the name of it right here referring to the line on the graph. It says write an equation for the line that's perpendicular, perpendicular to N, and whose y-intercept is 0, 5. So first of all, I need to figure out the slope of N so I can figure out the slope of a line perpendicular. So let's do that. The slope of this line, let's pick out 2 points that are on this line. So let's do this point that they have identified and this point right here. And if I make my slope triangle, it looks like it's 2, and then 1, 2, 3, 4, 5. So depending on how you look at this, if I travel from the first point, this one on the left, to the second point, I would go 5 to the right, which is positive in the x direction. But when I go 2 down, that's negative in the y. So it looks like the slope of line N, looks like the slope of line N is negative 2/5. Remember, it's your rise over your run, so it's the y change over the x change. So if it's perpendicular, then perpendicular slope, any line perpendicular that would have opposite reciprocal slope. So the slope would be 5/2, and it would be positive because it's the opposite reciprocal slope. So the equation of that line, I'm given the y-intercept equals 0, 5. So I'm going to use the y equals mx plus b equation to write this. So this is my slope-intercept. Since I'm giving the slope and the intercept, I can do it this way. So y equals my slope 5/2 x plus my y-intercept, which is 5. Now, if you were thinking of using the point slope form, I'd get the same equation, but I'd have to do a tiny bit of algebra. So off to the side, remember our point slope form would have been y minus my y coordinate of 5 equals my slope 5/2 times my x coordinate of 0. So this becomes y minus 5 equals, and x minus 0 is x, and so it would just be 5/2 x. And then lastly, I'd have to add 5 to both sides to get y by itself. And you can see how it is also equal to the exact same equation. They're the same, whichever form you use, whether you use point slope or you use slope intercept. And it said to graph this line. So I'm going to go and graph the y-intercept of 5. And I'm going to use my slope, which was 5/2. So sometimes it's hard to move off the graph and be accurate. 1, 2, 3, 4, 5/2 is somewhere right in here. So sometimes I use the reverse movement. So positive 5/2 is the same thing as the 5 being negative and the 2 being negative, because a negative over a negative is a positive. So I sometimes think this when I do the graph. So coming back to my y-intercept, I might go down 5, which is negative, in the y, 1, 2, 3, 4, 5, and then go over to 1, 2, to create another point that would be on the line, but I'd be doing negative movement in both directions. And when I pencil in this line as best I can, I know that these two lines are perpendicular. I'm going to draw my right angle mark. And great. So next, let's take a look at the second part of the problem. It says write an equation that is parallel to N that passes through the point 3, 1. So if they're parallel, they have the same slope. So I know the slope of my line is going to be negative 2/5. It has to be the same as my original line, so they're parallel. So my equation then would be y minus my y coordinate of 1 equals my slope. Parallel lines have the same slope. X minus my x coordinate of 3. So you can actually graph this line without putting a slope-intercept form. Let's go up to the graph, and let's graph the point that's on it. It's the point 3, 1. So let's go graph 3, 1. So if I go over to 3 and up 1, I've got this point right here. So now I know my slope is negative 2/5. So let's do down 2 and to the right 5, for instance. So down 2 and to the right 5, 1, 2, 3, 4, 5 to get another point on my line. And I could do the reverse movement. That means I'm going to do, in this case, a positive 2 over negative 5. That would be the same movement, same line. So different movement. Up 2 would be positive, and then to the left 5, 1, 2, 3, 4, 5, just gives me another point on that same line using my stair steps. So if I use a straight edge or draw as neatly as I can since I'm on my iPad, you'll see that I have just drawn two lines that are parallel because they both have the slope of negative 2/5. So parallel lines have the same slope, and perpendicular lines have slopes that are opposite reciprocals. So let's take a look at 12.3. You'll find that on page 92 of your workbooks. So the first question says line L represents this equation. So this is the equation of line L. It says write an equation of the line perpendicular to L passing through 6, negative 4. Call it P. So for line P, I first need to figure out its slope. So I can tell the slope of line L is 2/3. But since P is supposed to be perpendicular, I need to figure out perpendicular slope. So it would be the opposite reciprocal. So I would have negative 3/2. So the equation for line P would be y minus 4, since negative 6 fours on it, equals negative 3/2 x plus 6. So this is the equation for line P, and line P is perpendicular to my original line L. So now let's take a look at number 2. It says write an equation of a line perpendicular to P. That's the one we just wrote in number 1. That's that line right there. Passing through 3, negative 2. So again, I need my slope to be perpendicular to P. So slope that would be perpendicular to P would be positive, that's the opposite, 2/3. That's the reciprocal. So now I would have y, and the y coordinate would be a plus 2 because y minus a negative 2 equals 2/3 x minus 3. And this is the equation for the line N, and line N and line P are perpendicular. So it says, what did you notice about lines L and N? Okay, let me go figure out which two of those are. So line L is the very first one I had. This one I'm highlighting in yellow. And line N is the last one I wrote, this line right here. And what did we notice? Well, I'm looking at the two lines, and I'm noticing they both actually have the same slope. Their slope in both cases was 2/3. Let me change that back to something we can see a little better. I noticed that line L and line N have the same slope. In other words, they'd be parallel to each other. So if I could picture this over here, somewhere I have line N and somewhere else I have line L, and they'd be parallel the way they're drawn. So then it goes on to say, what do you notice about lines L and N, and does this always happen? So notice how P figures into this. P is perpendicular to L. P is also perpendicular to N. So if I graph a line that could be P, it turns out it would be perpendicular to both of those lines. So if two lines are perpendicular to the same line, then we have learned that they are parallel to, and I use the abbreviation for parallel, to each other. So we've shown that if two lines are perpendicular to the same line, then they're parallel to each other. And we also did that when we did the construction of parallel lines back in Unit 1 in September or October when we were first together. Let's take a look at our practice 12. So let's take a look at number 1 on practice 12. It says for each equation, is the graph of the equation parallel to the line shown, perpendicular to the line shown, or neither? So this is all about slope. Turns out this problem, I need to figure out my slope before I can talk about parallel and perpendicular. So let's use my graph to figure out the slope. So let's pencil in a slope triangle. Looks like I move up 1 and 1, 2, 3, 4, 5 to the right. So it's rise over run. So 1 over 5, and both movements are positive. Up 1, 5 to the right. So it's a positive 1/5. So I need to look through my problems and determine the slope of each of them. So the slope of this one says it's 0.2. So now I need to think about how that compares to 1/5. Why don't you grab out your calculator and do 1 divided by 5. And when you do that, you find that 1/5 is also the fraction or the decimal 0.2. So this is y equals m times x, where my m is 0.2. So this would be parallel. Same slope. So then I can tell when I look at the second one, they're not parallel. The slope's -2. So definitely not parallel. Let's figure out what my perpendicular slope looks like. So it's the opposite reciprocal. So that would be 5 over 1, and it would be opposite, so it'd be negative. So I'm looking for a -5, basically. So then this guy is neither. He is not parallel because it's not a slope of 1/5, and it's not perpendicular. It's not a slope of -5. C is also neither, because it's not a slope of 1/5, nor is it a slope of -5. So D is in point slope form, and I can see my slope right here. This is my y minus k equals m times x minus h. So my slope is -5. So I know this line is perpendicular to the one in my graph because their slopes are opposite reciprocals. And then in E, I can see that my slope is 2. And I know that it's neither, because neither my line nor my perpendicular line have a slope of 2. And F is in the form, this is my AX plus BY equals C. This is my form, I can't see my slope. So out to the side, 5x plus y equals 3. Remember what we had to do here? We had to solve for y in order to figure out my slope. So I'm going to subtract 5x from both sides, and I get y equals -5x plus 3, and I can see that my slope's a -5. So then I know that this line is actually perpendicular to the one in my graph. Let's jump over and take a look at on page 95. Let's take a look at number 4. So it says select all equations whose graphs are perpendicular to the graph of 3x plus 2y equals 6. So we have the same situation we have every time my line is in the form ax plus by equals c. It looks like it's happening in choice A and choice B and choice C. When my line is written in this form, I cannot see my slope. I don't know what the slope is. So I have to solve for y. So let's take our 3x plus 2y equals 6. And let's solve this for y. I'm going to subtract 3x on both sides. And I get 2y equals -3x plus 6. I'm now going to divide everything by 2. And when I do that, my y equals -3/2 x. I'm just going to pull the entire fraction out as a coefficient, and 6 divided by 2 is 3. So I know my slope is -3/2. I can now figure out my perpendicular slope, and I can use it to come over here and start circling all the choices that have my perpendicular slope. I am, for A, B, and C, going to have to solve for y. Please finish up this number 4 as part of what you're going to be posting in Google Classroom. So let's take a look at number 5. It says match each line with a perpendicular line. So everything in column A matches to something in column B, something that's perpendicular. And I remember that perpendicular lines have opposite reciprocal slopes. So basically, you have to go through and determine all 6 slopes in this problem. Then, after you're done with that, you're going to match something from column A to something in column B that are opposite reciprocals. So something like C, I can already see the slope. It's right there. But in B, I cannot see the slope. I'm going to have to, just like we did in 4, you're going to have to solve for y out to the side to figure out its slope. And then for something like A, I'm not told the slope here either. I'm going to need to make sure I use my slope formula, which is the difference in my y values over the difference in my x values to figure out the slope of that line. Once I know the slope of each of these lines, and I find the slope of each of these lines, I can then match up what are opposite reciprocals, what are perpendicular to each other. So take a look at the next page. So let's take a look at number 7. This is reviewing an important concept that's been with us since lesson 6 on circles. It says select all the points on the line with a slope of -1/2 and that go through the point for -1. So we're going to use an important concept. If a point is on a line, on a circle, on a parabola, on any of these different graphs, then it makes the equation true. So this has been an ongoing type of problem we've been looking at, first in circles, then with parabolas, and now with lines. So what I need to determine is the equation of my line. So I know my slope is -1/2, and I know through it goes to the point for -1. So my equation, y minus my y value, y plus 1, equals my slope times x minus 4. So this is actually 5 different problems. I need to substitute. There's not really enough room to do my work here. You'll see when you look in the locker, it's very scrunched together. But I need to plug in for my x a -2 and for my y a +2. And I'm trying to see if it makes the two sides equal. If I get, for example, a 3 equals 3, perfect. Then the -2 is on my line. I got the same answer on both sides. If I get something that doesn't make sense, like 3 equals 2, then I would know it does not make the equation true, and -2 would not be on my line. So you'll need to finish up these problems so that you can post them for the assignment in Google Classroom. Thank you.